This lesson will teach you how to repair an electronic level transmitter. Several things, or sometimes a combination of things, can cause an electronic level transmitter to operate poorly. For instance, the measurement section may not be installed properly as outlined in Module 2.13, Float and Displace type level installations. Make sure the measurement section is fully commissioned. Check all the valves. The wiring may be at fault. If wiring problems are suspected, check the wiring as detailed in Module 2.21. Install an electronic instrument control loop. The transmitter section may not work properly because the installation does not conform to the specific manufacturer's specification. For instance, a Fisher 2340 transmitter has maximum and minimum power supply voltage limitations. The transmitter has maximum load resistance tolerances. And it has ambient temperature limits. All these specifications must be met for the device to work properly. Now we will assume the installation is correct, the wiring is okay, and all specifications have been met, but the transmitter doesn't work properly. Begin looking for the problem by identifying the symptom. For instance, the transmitter may have consistently low or high output. It may be erratic, or the transmitter output may not agree with the true level. Many times, the symptom will tell you that the trouble is external to the transmitter, such as a stuck valve causing an erratic level readout. Put the associated controller on manual. Disable any shutdowns, startups, or alarms in the level loop. Determine whether or not the level transmitter and loop are intrinsically safe. If the transmitter and loop wiring are not intrinsically safe, get a hot work permit before you remove the cover from a powered transmitter. We will assume our transmitter is intrinsically safe. Make sure normal power is reaching the transmitter plus and minus terminals. After verifying the power is present, raise and lower the level by manipulating the block and bleed valves. Be sure to wear proper safety equipment such as goggles, gloves, acid suit, air pack, and so forth. Be sure you dispose of the process fluid safely. If the level transmitter is internal, you may have to remove the transmitter to stroke it. As the level raises and lowers, make sure the rotary shaft twists. Observe the metrosite vane at 0% level and at 100% level to make sure the rotary shaft does twist. Suppose the rotary shaft didn't twist. What would you assume? The torque tube could be broken. The displacer could be sunk. Or the shaft clamp nut could be loose. The shaft clamp connects the torque tube rotary shaft to the input shaft assembly. To check the clamp nut, remove the access cap. Loosen the clamp nut with a 5/16 of an inch hex nut driver. Loosen the vane set screw. Center the vane on the lamination notch. And center the vane so it has vertical clearance between the laminations. Tighten the set screw. Push the vane to the left and right through its travel. the vane must not drag on the lamination. If it does drag, loosen the Metrosite mounting screws and reposition the Metrosite. Flick the vane. It should return to the center of the laminations. If it does not repeat, the flexures in the input shaft assembly may be broken. Unplug the reversing terminal strip. Remove the terminal strip wires. The input board. And finally, the input shaft assembly. Replace the input shaft assembly if there is obvious damage. Reassemble the input shaft assembly Metrosite and realign the vane arm on the lamination. Be sure to set the vane at midpoint between laminations. If the transmitter is left-hand mounted and the displacer is free hanging, move the right side of the vane even with the right side of the lamination notch. Hold the vane there, then tighten the shaft clamp nut. If the transmitter is right-hand mounted and the displacer is free hanging, you would push the vane until the left side of the vane is even with the left side of the lamination. Hold it there while you tighten the clamp nut. Now, when the level moves, the vane will move. The vane arm is positioned correctly. It does not drag or bind on the Metrosite. The transmitter should work properly if no other problems exist. Before we deal with other transmitter problems, work exercise 1 in your workbook. In the last segment of this lesson, you learned how to adjust the Metrosite vane. To continue our lesson on troubleshooting, we will assume the Metrosite vane is centered correctly and does not drag. And the measurement section is working properly. But the transmitter's operation is not satisfactory. Likely causes can be: the transmitter is out of adjustment or calibration, one of the electronic components, such as the Metrosite or circuit board, is in bad order, or the span or zero potentiometer could be in bad order. Make a visual inspection of the transmitter parts. Make sure the printed circuit boards are plugged in securely. Look for broken or loose wires. Make sure the Metrosite vane is in the proper position relative to the displacer. Make sure the transmitter action is correct. When the letter A is on top of the reversing connector, the transmitter action is direct for a right-hand mounted unit and indirect for a left-hand mounted unit. When the letter B is on top of the reversing connector, the transmitter action is reverse for right-hand mounted units and direct for left-hand mounted units. If you need to change the action, remove the connector, turn it over, and reinstall it. Be very careful not to bend or spread the pins. Now you can check calibration. Drain the chamber of process fluid. Measure the output current with a very accurate current meter. Some transmitters have a resistor in the output current path, so you can measure the output in terms of voltage rather than current. Refer to parts lists and instruction manuals for your specific transmitter to see if it has the output voltage option. Set the output current at the low end of the scale. This is a 4 to 20 milliamp transmitter, so set the output at 4 milliamps. Fill the chamber. Use actual process fluid or use water. Remember to compensate for the difference between the specific gravity of water and the specific gravity of the fluid that will be measured. Set the output current to 20 milliamps with the span control when the level equals 100%. Repeat span and zero adjustments until recalibration is accurate. Now we will assume that calibration didn't fix the problem. We can assume that the problem is either in the output board, the input board, the metrosite, or a bad span or zero potentiometer. Let's quickly review the steps we took to isolate the problems to the electronic section. First, we verified that the measurement section was commissioned correctly. Then we checked the loop wiring and also verified that the normal power was at the transmitter. Next, we verified that the metrosite vane moved when the measurement section moved. These steps proved whether or not the entire measurement section of the transmitter worked properly. We then centered the metrosite vane and made sure it did not bind or rub the lamination. Our next step was calibration. During calibration, we checked the entire system. If the transmitter still doesn't work properly after you attempt calibration, you can replace the entire transmitter section. Or you can further isolate the problem. For instance, check the oscillator by placing an AC voltmeter across pins 3 and 4 of jack 3. You should read approximately 1.6 volts AC on this voltmeter. Check the metrosite by measuring the voltage at the secondary winding outputs, jack 3 pins 1 and 2, and jack 3 pins 5 and 6. The voltage should be between 6 to 8 volts peak to peak, depending on where the metrosite is located. Move the metrosite. The AC voltage should vary between 2 and 4 volts on this meter. If it doesn't, replace the metrosite assembly. The metrosite winding can also be checked with an ohm meter. The metrosite primary provides 36 plus or minus 2 ohms between pins 3 and 4 of jack 3. The reversing plug must be unplugged when you make the measurement. Each secondary winding produces 365 plus or minus 10 ohms. Read one secondary between pins 1 and 2 of jack 3. Read the other between pins 5 and 6 of jack 3. The reversing plug must be disconnected when you make the resistance measurement. Replace the metrosite if necessary. If you replace the metrosite, recalibrate the transmitter. The two circuit boards can be checked by a process of elimination. Remove a board, replace it with a known good one. Check the transmitter operation. Remove the power when unplugging and plugging boards into the transmitter. Depending on your plant's policy, either repair the transmitter board as per the manufacturer's instruction, or send the defective board to the factory. Recalibrate the transmitter. If the trouble is still encountered, check the continuity of the span and zero pots. Check for broken wires, and check the plug-in pins and jacks for mechanical damage. Now work exercise 2 in your workbook.